All right, so 9.3, we're going to look at exponential functions. So y'all, before we get into graphing the exponential functions, we're going to introduce a new constant to you. And they use it a lot in exponential functions that we're going to use later on in this chapter 9 material. But for today, they just want you to learn about it and how to use it, your calculator, to find the value of it. So it's a constant like pi. Pi deals with circles. This constant deals with investment type functions. Like if you wanted to invest money and see how much you had after so many years. This constant is used in that. So if you take business math, you'll get into it more. But this looks like a little e, and we call this Euler's number. So we'll punch it in on the calculator because remember, it's a never-ending decimal like pi. So I'm going to show you how to find it on your calculator. So let me share my calculator screen. So y'all, on the calculator, if you'll look right above that division, you'll see a little blue E. So if you want to know the value of E without an exponent, I punch the second blue button and then the divide button, and that puts E on the screen. Now when I hit enter, and we'll estimate this about 4 decimal places, but when I hit enter, this thing's approximately equal to 2.7183 if I'm going to round it 4 decimal places. So you look at the fourth number after the decimal. If the fifth number's 5 or higher, round it up like I did to a 3. If it's 4 or less, you would leave it at 2, okay? So you got to be able to round off in this section. Now, if I want to use the E with an exponent, I'm going to hit the second button, and then down here to the left of the 4 is the LN button. If you look right above that LN button, there's a blue E with an X there. So I hit second and LN, it'll bring E on the screen, and it's ready for the exponent. So second divide just gets you the E. Second LN gets me the E with the exponent. Now you could do the second divide and then hit the caret thing down here to get the exponent.
Could we all just about to say, can we do the second arrow with that and that'll still work? Because that's how I use different exponents. I just hit second
Yeah,
pi.
if you get the arrow up, so like if I clear this screen and I hit second divide and then arrow up, it's going to put it up there also.
Yeah.
All right, y'all. So let me go back. So like I said, E was 2.7183 rounded off. So for the first two problems, to get you used to the E, they want us to use a calculator to approximate the 4 decimal places. So y'all, the first one, they're giving me E to the third. So let's go punch this in, E to the third, and see what we get. And we want to round this off to 4 decimal places. So if y'all want to try that, I'll let y'all try that.
It's 20.085. You said 4 decimal places, 0.85, and then 5.
Okay, there you go. Perfect. So is that what everybody got on that one? So I'm not hearing any no's, so that sounds good. All right, y'all try this one. E to the negative 3.45. And y'all, everybody's calculator do this, even the ones y'all got off the phone apps, okay? They'll all do these. So if I was doing that, and let me clear my screen here. So like you said, you could hit E, second, divide, get your E, and then use the arrow up to get the exponent. And that was a negative 3.45.
I got 0.0317.
0.0317, you said?
Yeah.
So let's see. Yeah, because after the 7 was a 4, so you got to leave it a 7. Good job.
So that was my question. The last one, Mr. Eugene. When we did 20.0855. I thought when it's a 5, you round it. Like so, 8 was 8 supposed to be 9? Because that kind of confused me.
So that was E to the what? 3 on that one?
Yeah, was 8 supposed to be 9? That's why.
So 085. So the fourth number was that 5.
Okay.
Now, to tell me what to do to that fourth number, I'm going to look at the fifth number. So the fifth number, if that fifth number where the 3 is, if that was a 5, 6, 7, 8, or 9, I'd have rounded that 5 to a 6. But since it's between 0 and 4, being a 3, that means you leave that 5 the same.
Now, hold on. You will calculate to approximate. Okay, got it. Each of them is 4.
So okay, remember, got it. To round 4 decimal places, look at the fifth number, okay?
Okay. So it would have been different if it said 3, and then 4 on that one, because then it would have been what I thought.
Well, if I'd had 0.08555, if that 3 was a 5,
right, you would have rounded it up.
Then I'd have made that a 0.0856. Okay, there you go. All right, y'all. So just a little bit to get you used to that E on your calculator. Now we're going to look at graphing. So graphing these exponential functions, these are graphs that look like y equals a to the x. Your variable is now the exponent. A is what you're going to call the base. So you'll have a number here like 2, 3, 5 or something. What's going to change and determine the graph is going to be this exponent where you're putting in your numbers, okay? Now, you got to recall a few things on this. Y'all, what does it equal if I take any number you give me and raise it to the 0 power? What do y'all remember does that equal? And y'all got a calculator, so on that calculator, punch something like 5 to the 0, 3 to the 0, and see what that gets you.
1.
That's going to get you a 1. No matter what that number is, if you raise it to the 0 exponent equals 1. So on these graphs, anytime that x is a 0, my y value will be 1. Okay. Now, another thing about these exponential functions, when you graph them, they're continuous graphs. That means they don't have any undefined parts. They're just a smooth curve. Okay. So we're going to play with some of these. Now, remember, exponents can make these bases get big quick. When you square a number, cube a number, raise it to the 4th power, they're going to get large quick. So try to use small numbers probably on those exponents when we graph them, okay? So I'm going to give you an example of a number here for the A, and then I'll give you an example using a fraction for the A. So this first example we're going to graph y equals 2 to the x. Now, these are going to be quick on the calculator, but I just wanted to show you a little bit about graphing them. So I'll go out about 10 on this. How about 8? All right, let me let one in real quick. All right, so I'm just going to go out about 8. All righty. So for this one, I'm going to keep my numbers a little small that I'm picking. So I'm going to pick a 0 first. So y'all, what's the y value when I put a 0 in for that x? That's going to give me 2 to the 0.
So it's 1.
It's going to be 1. All right, I'm going to put a 1 in for that x. I'll put a 1 in for the exponent, 2 to the first power. That's going to give us 2, because anything to the first power equals itself. All right, y'all, let's put a 2 in. So now you got 2 squared. So that'd be what, 2 times 2, which will give us a 4. And then one more. And I want y'all to start seeing how they sort of grow quick.
6.
So 2 times 2 times 2.
That's 8.
8, there we go. So it's going to cross at 0, 1 here. At 1, 2. And y'all watch it. These graphs, if you remember, COVID started out flat, but then in COVID graphs started shooting up really quick when people were getting infected more. So that's what these graphs do. Over here at 2, I'm up here at 4 now. But look at this. At 3, we're doubling, and at 3, we're going all the way up to 8. So these graphs double quickly. So if I'd have put a 4 here for the x, this thing would have doubled all the way up to 16. Now, this graph is going to, it does like a horizontal asymptote. And then the right side, it's just going to keep going uphill. And this side, if you put them negative exponents, those negative exponents are going to make these values keep coming down and down until they try to get to that 0, okay? So notice what this graph is, your exponential graphs. When we go to math lab, on the ones where you got to actually graph, this one, they'll give you pictures, but it's going to be the graph that looks just like these shapes, okay? Y'all, let's try a fraction. So I'm going to do y equals 1/5 to the x. All right, let me make another y table here, x and y graph. I'm just going to go out about 5, y'all. So I'm going to put a 0 in here. So this fraction, 1/5 raised to the 0. What's that going to equal?
1.
1.
1, there you go. And then if you use the 1/5 to the first power.
It's gonna be 1/5.
1/5.
There you go. And let's try one more that way, and then I'll show you. I'll probably use negative exponents on this one to sort of show you what's going to happen.
That's
But
gonna
if
be
you
1
put
over,
it, oh, I heard it 1 over
25.
25. There you go. Good job. You got to square the top and bottom when y'all got these exponents on a fraction, okay? Now, y'all, that means this side is sitting here at 0, 1. At 1 and 1/5, boy, 1/5 is not very high up. 1/5 is pretty close to that 0. That 1/25 is even closer to 0. So it looks like the right side of this graph is doing what this one up here did on the left side. It's trying to get to 0. Y'all, next would have been 1 over 125 if you'd have cubed that. That's getting even closer and closer. So let me show y'all what's going to happen if you put negative exponents on this. So if I had 1/5 to the negative first. So y'all, here's a little rule about negative exponents. We want to make these exponents positive before we evaluate it. So to make a negative exponent positive that follows a fraction, you flip the fraction
Oh.
and make the exponent positive.
So that's what we're gonna do all the time when it's a fraction. We won't put in the calculator 1 over
Well,
5.
you could put it in like this, but when you do this, it should give you the same thing I'm going to get, because 5 to the first is 5, and 5 to the first power is 5, right?
Yeah, that's what it gave me 5.
So if you push that in the calculator with that being a -1, it should have gave you a 5. Now watch this if you put a -2 here. So y'all, the first step, make that exponent positive. You're going to flip
Flip it.
the fraction.
And it's positive 25.
Yeah. Because 5 divided by 5 is 5, and 5 squared is definitely 25. So see, the left side's getting bigger like the right side of the whole numbers. So the fractions, instead of going uphill, they're going to come downhill. So y'all, at this -1, we're at 5. And I don't even have enough room for -2, because that thing shot way up here at what, 25? So fractions, instead of going uphill, will come in sort of downhill and try to get to that line, okay? So I'm going to tell y'all the truth. Knowing that whole numbers go uphill left to right like that, and the fractions go downhill, you can pretty much guess the right graph without even using your calculator, because they got 4 distinct graphs on these things. Look at the one they had for what I just did. Ours came down and went to the right for the fraction. They got one going under the line. Well, we don't got nothing that can make the y values negative. This one is going uphill like if that was a whole number. And y'all, this one looks like a cube down in here. So you'll be able to tell pretty quick which one's going to be your picture on those, okay?
Hold on, Mr. Eugene, before you turn from that, because I'm trying to.
Okay.
Okay, I got it. Thank you.
Okay. All right, y'all. So y'all have a few of them doing graphs where you're just going to really plug them into your calculators and watch this, y'all. Let me do one more that I can show you on the calculator here. One more graph, and then we'll start moving them up, down, and left and right and all that fun stuff. So f of x equals 4/9 e to the x. Now this e is what's really being affected by the exponent. It's not a fraction with the exponent, it's the e with the exponent. So remember, e is 2 point blah, blah, blah. So this graph, you'll see, should go uphill. Okay? Now, if that fraction had the exponent behind it without the e, it'd be a different story. But I wanted y'all to see this, and because the exponent's really affecting the e. So on that one, I'm going to show you how to put that in my calculator.
So in the calculator for the x, would there be a number for us to put, or will it always be x?
It'll always be
There we
X.
go. Okay.
So like that one, I'm going to do alpha y equals to do that 4/9. Make that look like a fraction. So remember, always use alpha y equals for your fractions. And then e to the x, I'm just going to hit second ln and get that e right there. And I'm going to put me x there. So you really, yeah, want it looking just like what they did. And then let's hit the graph. And there you go, sort of. Let me put mine on a regular window again. So the standard will put that on a 10 by 10. And there you go. Now, look at the y values on this table by hitting second graph. So let me go to 0. So the reason this is 4/9 on this one is because you had e to the 0, which equaled 1. And 1 times that 4/9 is why you got a 4/9 when this one is 0, okay? But the e to the 0 was still 1 and got multiplied by the 4/9. So notice how these numbers get huge. A 6 for the exponent, you're at 179, 487, 1300. It don't take long for exponential graphs to really have high values, okay?
Will we do anything where we need this table, Mr. Eugene?
No, I just wanted y'all to see them numbers got big.
Oh, okay, okay.
Yeah. You just want to be able to graph them and pick out a graph on those, okay? So those will all have like 4 pictures for you to pick from. But y'all, a little bit later on in here, we start getting into transformations. So y'all remember back in section 7.2, we did transformations. We moved them graphs up and down. We shifted them left and right. And we even reflected them over the x-axis. So now we're going to do transformations to our exponential graphs. The ones that start out y equals a to the x. The first move I can do the vertical transformation still. So y'all remember, to do a vertical transformation, I had y equals a to the x plus or minus b. I'm adding a number at the end, or I'm subtracting a number at the end of the function. So y'all, as b is positive, even back in 7.2, if you added a number to the end of that function, what did it do? On the vertical, it moved my graph upward. So it's still going to be true. If you add 5 to the end, it's going to move you up 5. If the b is being subtracted or negative, well, y'all, if y'all had an x squared graph and you subtracted 3 from it, that moved your graph down 3. So adding at the end of a function up, subtracting at the end of the function down. Next, we had the horizontal. So if y'all remember back in 7.2, when I moved my graphs left to right, I was attacking those x's inside the parentheses, right? Well, we're still going to attack the x. So this time, a to the x plus or minus some number. Y'all notice the difference. On vertical, I wasn't up here with the exponent when I added or subtracted my number. But to do a horizontal, I'm actually up here with the exponent, okay? I'm attacking the x still. So if c is positive, well, when y'all was attacking the x and y'all was adding to it, it moved that graph to the left. So adding to the x is still going to move you left. And if that c is negative, it's going to move my graph to the right. Okay, so these are pretty much the same as they were in 7-2. It's just now your x is an exponent, okay? And it's not something being squared or cubed or something like that. All right, y'all, I'm still going to reflect it over the x-axis. To reflect it over the x-axis, it's going to be the same as it was in 7-2. I'm going to put a negative in front of my function. So if I throw a negative in front of the base, that's going to reflect it over the x's. So y'all, that was the only three we had in 7-2, but in 9.3, we get to add one more reflection. We're now going to look at how to reflect it over the y-axis. So to reflect it over the y-axis, we have a to the negative x. We make the exponent negative to flip it over the y-axis, okay? So y'all, keep track of these moves because we're about to play with MathLab, and I want y'all to pay attention to a few things we got to do in MathLab when we're graphing these, okay? Now, we'll say on these graphs, we're going to use the exponential tool that looks like it's curving up. Okay, so we'll click on the exponential tool, and then we'll click anywhere on the graph like you did back in 7-2, and it'll draw the graph, and then we're going to use them little controls to move it left, right, up, down, and all that fun stuff. Now, the big thing in this section, when it opens up that window with the horizontal, vertical, and all that, in the bottom left side, we got to put what base our problem is. Whatever number's in place of the A, we got to let MathLab know our base. By default, it's going to have that little e in there, okay? So y'all, let's go. Got your moves? Remember those because we're about to go play with the graphs. So these are going to start. All right, so let me skip up. These are the ones where you just graph like I showed you just now. The whole numbers. And then they'll have one with a fraction and stuff like that. So I think what I'm wanting to get to, that's the one with the E I showed you. So I think we're wanting to start at about number 7 here.
So this whole section is the calculating and graphing, really.
Yeah, other than the last two problems I'm going to give us later on, the last two problems deal with a formula. But in the first two deal with the E stuff. But yeah, now these from 7 through 11, we got to figure out what these moves are doing. So let me show y'all on this one. I got f of x equals 2 to the x plus 4. Now, what's that plus 4 doing to my graph since I'm adding it to the x?
Move it to the left.
It's going to move it to the left. So we come down here to D where it says it moved it to the left. Now you got to put the base in here. My base was the 2. So right, y equals 2. It's already got the x there. And then it's going to shift it 4 units to the left. So y'all, let's check that answer. So good job. Now we're going to graph it. So I'm going to click to enlarge my graph. Remember, grab the exponential tool, second row, second tool, exponential, and then click over here anywhere. It don't matter where you click. It's going to draw that graph the same place every time. So we did 4 units to the left. So go to the horizontal and let's slide that to a -4. All right, I got the move done. Remember the last thing I said you had to do? Go down here in the bottom where it says base and change the base from that E to a 2 that we're using.
Okay.
If you don't change the base, the graphs look pretty much the same, but they'll be off a little bit, and MATLAB will get you, okay? So make sure you change the base. Now save that, and then you're going to check your answer.
And the base is gonna always be the leading coefficient, which is 2 in that one.
Yeah, now I got one that's a little mixed up, so I'll show you that one when we hit it.
Okay.
All right, so y'all, this one we got a graph first. So look what we got, 5 to the x minus 3. So let me move this over just a little. So we got 5 to the x minus 3. So grab your tool first, click on your graph. So y'all, I need to know what's that minus 3 doing to my graph if it's added to the end of the function.
It's going down.
So going down, it's going to be vertical down to -3. And what else we're going to do to this?
We're gonna change the base to 5.
Change the base to a 5. All right, y'all. So that's the only move we had was that thing going down 3. So we're going to save that. And then check our answer. They're not too bad if you remember that base, okay?
Yeah, that was good. That was good that you drew that because I drew it too. And at first I didn't know why, but now I know. And I'm like, okay.
Now, after we graph it, we got to actually tell it what we did. So look, when you click the first arrow, we're starting with y equals what? Well, we started with the graph of y equals, where's my base down here? Oh, here it is down here on the bottom.
X.
5 to the x. Whoops. Now,
Okay.
and then we already know what we did, right? We went down 3.
Okay.
So click that. So some are going to have you tell what you did first. Some are going to have you graph it first, like this one. Oh, this one's got a lot of moves. You're going to like this one. So let me click this. Let me move this down so that y'all can see the problem. All right, y'all. I know my base over here is a 2. So let me grab this tool and click somewhere. So this 2 up here is like it's being added to the x. They just got it out of order. Think of this like a -x plus 2 if you want to. But that 2 is positive up there. So when
it goes left.
it's going to go left 2. So go horizontal first. Let's move that left over here to 2. -2. All righty. Now, that x is negative. What did we say it's going to do if I made the x negative on the exponent?
Go down.
Oh, not yet, remember.
Or go right.
Look at your 4th one that we wrote down on the 4th transformation.
Reflect over the y-axis.
Reflect over the y-axis. Anytime that x is negative, y'all, you're going to come down here and click reflect over the y-axis. So that turned it around, basically. Now you got a 2 at the very end that's positive. What's that doing? That +2. Remember, it's being added at the end of my function. So that's your first move we went over.
Go up.
Going to go up. There you go. So vertical, go up 2. So it moved it up. And now look here, my base is a 2 already. It must have saved that from earlier. So save this one. And then check that answer. Now, y'all, you got to go in order on this one, okay?
That's what I'm saying, like that one, because it has more. So, yeah, explain the order.
You got to go in order. So the 2 was the first thing we seen in the exponent. So we had to see what that positive 2 did. Then that x was negative was the next thing they did. So we had to see what happens when the x's are negative. And that was that y reflection. Then at the end was that +2. So we had to do what it had to
Vertical.
click on and
And
go
go
up.
up.
So just go in
So-
order of the actual transformation moves, okay?
So it looked like we didn't pay attention to the 2 at the exponent 2.
That one first, exactly.
Okay.
So let's see. That one made me go left 2. Well, hell, they all got left 2 units. We reflected it across to Y, so it's down to A and B. And then we shifted it
Up.
2, so it has to be A on that one, okay?
Okay. And then what kind of graph did we make that one? Because we didn't choose did we choose the exponential tool on that one?
Yeah, we did the graph before it. So here's another one like it. Watch this. We're going to click to do the graph first. All right, let me move mine out of the way. So I'm going to click the exponential tool every time, okay?
Mm-hmm.
And then click anywhere. So the first thing I'm looking at is the 1 in the exponent spot. What is that +1 doing to my graph?
It is moving it up 1.
Well, that ain't at the end of the function member.
Oh, it's moving it to the left.
When the numbers are where the exponent is, it's left or right. So that one's going to go left 1 because that one's positive. Now you got a negative x. What's that doing?
The negative
Oh,
x
reflects over the x's, my bad.
going down.
So flex over the y-axis, remember?
Yeah.
So I started with the 1. It was positive, move me left. The
Mhm.
x was negative. I reflected over the y-axis.
Right.
Now at the end is the +1 that's going to do what?
That's gonna tell us
move
if
it
it's up or down.
Yeah, move it upward.
So that's positive. So we're going to go up 1 on that, okay?
Mm-hmm.
Save that. Check our answer. And then remember, this one wants me to go left 1, reflect on the Y, so it's down to B and C. And then we went up 1, so you got to pick
Left
B on that
one.
one.
Then
Okay.
Okay, so that was just remembering steps. Got it.
Yeah, pretty much, huh?
Mm-hmm.
Now this one,
step by
this
step.
one, I would treat the 4 like it was in the back. Okay.
Mm-hmm.
So if you was to start doing the moves on this one, we're going to really treat this like it's a -2 to the negative x plus that 4, okay? They're just putting it out of order to mess with you. So the first thing I'm looking at is that negative in front of that 2 is going to reflect me across the x-axis.
Mm-hmm.
I mean, hold on, let me say priority on this one. I would start with the negative x.
Negative
Yeah.
x.
Yeah.
Yeah.
Okay.
So the negative x is going to reflect me over the y-axis. The -2 is going to reflect me over the x-axis. And that +4 would be like it was at the end over here being added. So that's going to go up 4 units. So we need one of these that reflects across both of the axes and went up 4. So let's see.
That way.
So what did y'all say?
You
Letter
said
A.
so it's B. Wait, is it A?
It's
A.
A.
I was gonna see
Okay.
A's got the y-axis
The
because
y
it's
and the
negative
x,
x.
and then it goes up.
And
Okay.
it
Yeah.
went up. And my base I'm starting with, you don't have to put the negative. All you got to do is put the 2. Don't write the -2 on the base, okay? The base is just the number without the sign. Because that, where it says we reflected across the x-axis, that's pretty much telling you got a negative there doing that, okay?
Okay, got it. Okay, that's what
Okay.
threw me out because it's worded different.
Uh-huh.
Okay.
Now, remember the order we're picking, y-axis, x-axis, and then we're going up 4 because we got to graph it in that order.
I thought we made that 2 negative. No?
No, you don't make that. No, the base has to be just a number without the sign.
Got it. Okay.
We would treat that negative like it's a -1 being multiplied by it, and then we took care of that when we said, well, right here, it reflected across the X. So that let us know that that had to be negative, okay?
Mm-hmm.
Now, click to enlarge my graph. Let me move it out of the way a little bit so we can see. So we're still grabbing the exponential tool. Click anywhere on the graph. So we first reflected across the y-axis. So click that. Then reflected across the x-axis. Click that. And then we said we went up that 4. So my base down here, what's my base? Because it's got an E. So my base will just be the 2. Don't write the sign on this either, okay? All right, so the base was 2. Then you save it and you check your answer. But y'all, that is sort of weird. If you go out of order, it flips it out and it marks them wrong for some reason. All right, y'all. 2 to the x plus 5 minus 3. You're going to start with the graph of y equals what to the x?
Two.
Okay, that's my base. Good job. Now, what's that 5 going to do? That 5 is being added to the x.
And it's positive, so it goes left.
So it's going to go left. Let me see if my computer let me. Okay, goes left 5. Good job. And then it's going to do what? 3. That negative
Down.
3 at the end.
Or down 3.
Down 3. There you go. So check that answer. All right, we're going to graph that real quick. So let me move this over a little bit to see that. So exponential tool anywhere. So you went 5 left, y'all said. So that's going to be horizontal left to negative 5.
Mm-hmm.
What was next? Minus 3. So y'all said that went down 3.
And the base is 2.
Oh, good job. The base has to be a 2. So if you think you did your moves right and y'all miss them, make sure you go back and look and see if y'all change those bases, okay? Alrighty, y'all. So next I'm going to show y'all a formula that uses exponential type stuff, okay? So let me get my paper turned over and then I'll share my other screen. All right, y'all. So the last 2 problems deal with the formula we're going to look at. And let me write the formula and then I'll tell you everything about it. Now, this formula is used to find out how much money is in an account over so many years. So T is going to be the time in years.
Is this the formula with like the I involved?
Not yet.
Oh, okay.
This one has a P and then parentheses 1 plus R divided by N, all raised to the exponent N times T. Whoops, y'all can't even see all that. There you go. So A of T equals P to the 1 plus R divided by N, all raised to the N times T. So
I remember this.
Y'all, A is the amount in the account after T years. So T represents time in years, okay? P is your principal or your starting amount. So I always use it as my starting amount. So if I'm investing 5,000, P gonna be 5,000, okay? Or you can remember it by it's your principal balance, which is what you started with. R right here. R equals your interest rate. Now, when I use this formula, my interest rate has to be in decimal form. Okay. Can't be in percent form. We got to turn them into decimals. N is the number of compounds per year. And a compound is when they go through the formula and they add your interest into your principal. So N will be the number of compounds per year. So I'll give you words like, let's see what y'all would think about this. What would quarterly be a year?
25%.
Well, think about it in how many times would I compound a year
5.
if I'm doing it quarterly?
4.
4 times. There you go. So quarterly would be 4. What about word like semi-annual?
12.
2. Annually?
1.
1. What else could I hit you with? Monthly?
12.
Daily?
365.
There you go. So those are the kind of things we're going to hit you with on the N. And then once again, that T stands for time in years. So T equals time in years. So notice, since you got T up here and the amount depends on T, this is what's making it exponential, because that's what's going to be changing over time. Okay. So y'all just get down and dirty on this formula here. So suppose $57,000 is invested at 5.5% compounded quarterly. For A, we're going to start with A. For A, they want me to find the function to which the investment grows after T years. So y'all basically, they want me to plug all this stuff up and come with a formula that I can use to see what happens after 1 year, 2 years, 3 years, or so on. Now, Math Lab will have the A of T part. We just got to fill in the rest of the formula, okay? So, let's see what we got to start with. Do we know our P? Well, y'all, they gave me that principle we started with, right? The starting amount they gave me was
57.
57,000. Then we got 1 plus, oh, R, that's my interest rate. Well, interest rate they gave me was 5.5%. How would y'all write 1/2 in decimal form?
0.5.
0.5. So that's going to give me 5.5%. So I just turned it 1/2 into my 0.5. Now, to turn a percent into a decimal that I can plug into this, you got to move the decimal left 2 units. So move it left 2 places here, okay? So that this will give me what, a 0.055. So notice I was able to move it once. So technically you got to add a 0 to get it moved twice, okay? So that turns into a 0.055 that I can now plug into my formula. All right, y'all. I'm compounded quarterly. So what's N going to be?
4.
All righty. And then out here is 4 times T. Now, here's the thing about this one. MATLAB will only take it if we simplify this part right in here. So y'all, let's bring down our 57,000. All right, one of y'all figure what that equals. On your calculator, punch in 1 plus 0.055 divided by 4 and see what we get. Y'all should get a 1 point something something.
Uh, 1.01375 or
375. So take it all the way out to all the digits they gave you. And then right here is what, a 4t. This is what MATLAB wants. It wants this stuff in the parentheses turned into a decimal. At that point, it'll give you a 100 on that one. So there's our A. So B. So it's only got A and B, but look at B. They want me to find the amount to which the investment grows after T equals 0, 2, 5, and 10. So basically, we're working this formula 4 times. We're going to put a 0 in for the T first. Then we'll put a 2 in for the T, a 5, and then our 10. Now, y'all, let me ask you this. If I make this T a 0, what's 4 times 0 equal?
0.
0.
Okay, so think about this. What does 1.01375 raised to the 0 equal?
0.
Exactly that. Oh, 0.
Oh, it ain't 0, remember? Would y'all tell me while ago that anything to the 0 power equaled what?
1.
1. So this whole thing equals 1 basically. And 1 times 57,000 is 50,000, 7,000, right? Well, if T is 0, no time has passed. So you better have what you started with, right?
Right.
All right, y'all. So let's see what we get when, well, we know what we're going to get now when T is 0. Now, these we have to round to the nearest dollar. So no decimal places, okay? So y'all done told me this one equaled 57,000. But y'all, let's okay, so I got my formula. Let me go to the calculator and show you how I just do these. So I don't need no graphing, so I'm going to quit that. Well, I'll show you a trick, though. If you want to graph this, watch what I can do. Y'all watch, this calculator's got a lot of power. So let me put you in my equation. 57,000 parentheses 1.01375 close parentheses. Now be careful on the exponent. We got 4t, but on the calculator you got to use a 4x. Okay. So always use x's when you're doing the graphing, no matter what they got here for the variable. Although it's a t, we're going to use the x. Now, y'all, I don't care what the graph looks like. I want to see what the table looks like. So I'm going to hit second graph. So how much did it tell me I had at 0?
57,000.
57,000. Let's go down to 2. How much do I got? What's that? 63,500 and 80. There you go. Next was 5 years. If I can arrow down to 5. So I'm on 5 years. That's giving me what? 74,000.
4,900.
Uh-huh.
Oh, wow. Okay, cool.
And then woo, I got an arrow down to 10. And I get 98,426.
But we have to round it to the nearest dollar.
So the last digit here. So I would have had my 57,000, 63,000. It's going to look just like the graph is giving them to you because it's rounding them off to the nearest dollars on those, okay?
Right, so we can write exactly how it is in the calculator.
Yeah.
Right?
Otherwise, you could come in and do what? Okay, the first one I'm putting in a 0, so I could do 57,000. Put in my 1.01375. And then for my exponent, I'd have 4 times 0. And when I hit enter, I better get 57,000 like we got. Okay. Watch what on the 10,000. I mean, on the 10 years, I'll just do another one at 10 years. So that's sort of the power of graphing. If I graph my functions, I can go to the table and get all these amounts, right?
Right, instead of just typing them in one by one.
Instead of having to do this every single time. So when we had 10 years, I think I had what, 98,000 something?
Yeah.
420. So round this into the nearest dollar. So that'd be the one spot on this.
So it's 426.
426, because that 0.9, that turned that 5 into a 6, okay? So y'all, yeah, or by hand, if whatever you like. The main thing is this is an investment, so your numbers better be going up, okay? If your numbers ain't going up from that 57,000, you probably made a bad investment, right? Makes sense though, don't it?
Mm-hmm.
All righty, y'all. So let's try a word problem. So on Melissa's 6th birthday, she gets a $6,000 CD. So a CD is like a certificate of deposit at a bank that earns 6% interest, compounded semi-annually. Let me see how to spell that. Annually. Okay, so she got a $6,000 CD, earned 6% interest, compounded semi-annually, so twice a year. So if the CD matures, that's when you can take them out when they're mature, and you can sort of start removing your money and stuff. But if it matures on her 16th birthday, how much money will be available? So if y'all got kids and y'all want to buy them CDs, you can use these kind of formulas to see how much they might have on their 16th birthday. Because you know what all these 16-year-olds want. They want little cars and all that stuff, right? So y'all, let's see how lucky Melissa is. So the first thing, we got to figure out how much time is going to pass between her 6th birthday and her 16th birthday.
10.
So we're going to be finding a 10 for this one. So y'all, I need my principal balance she started with.
6,000.
1,000.
And then we got 1 plus. R for her was 6%. So y'all turn that 6% into a decimal for me.
0.06.
There you go, because you moved it left twice. All right. N is semi-annually. So what did we say semi-annual was?
Did you say 2?
2.
I heard it, 2. There you go. So
Ow.
that means this will be 2 times T, y'all told me was
10.
10. Now let me see what they want us to do for this one. They want us to round this one to the nearest cent. So y'all, when they say the nearest cent, that means 2 decimal places. Like 45 cents, 33 cents or something. So we'll have something point, blah, blah. So y'all, this one, I would probably just punch this one in my calculator since it's the only value I got to find. So let's go play with our calculator. I'm going to clear this off. So we had 6,000 parentheses 1 plus 0.06 divided by 2. Or at that point, if you wanted to, the 0.06 divided by 2, you could have did the alpha y equals and made it look like a fraction and got the same thing. All right, y'all, let me arrow up for my exponent, and that was 2 times 10. All right, y'all, so we're about to see how lucky she is when I hit enter. Now,
6,000.
surely we want an amount higher than that, right? Ooh, did y'all get that?
No.
Oh, you know what? Let me see what happened here. Did I not do? I don't think
You
I
did
did.
1.
I think I did a 1 on mine. So let me start over. 6,000. 1 plus 0.06 divided by 2. Close that. And exponent was 2 times 10.
Mr. Eugene, for future reference, you can hit second enter and it'll copy it.
Oh, why am I getting the same answer?
Just because you put 10 at the top the first time. I thought you were just trying to do it over.
Second enter.
Hit second enter.
Oh, I did put the 10 on there.
Yeah, you put 10 on there.
Oh, I thought y'all was getting a different amount. Did y'all get 10,000 something like me?
Yeah, I did.
Okay. So she's a nice little happy little girl then. Round me off 2 decimal places, see what y'all get. So we know it's going to be 10,836. What's my next 2 numbers?
Should be 70.
Well,
Or
Remember,
67.
67. That's what I want right there. There you go. So 2 decimal places, you're looking at the second 6. And good job, it had a 7 after it. So you made that a 7 for that second 6. All righty, so y'all all got 10. So she made, they made about 4,000, almost 4,100 or so, So I don't know if it's enough to buy her a whole car, but it'll help, right?
A down payment.
It's a down payment for sure. See, with my kid, I'd probably steal the CD at 16, and Give her no junker, right? So y'all, that was 9.3. So like I said, there's no support with this.